here's how we set up that very first question. The very first question from the homework last night is basically area of a shaded region. If you think back to your geometry, when you did area of a shaded region, what you were doing is you were finding the large area, subtract the small area. In this case, your small area works out to be 96, 12 by 8. Everybody okay with that? Yeah. Your large area now becomes 12 plus x by 8 plus x plus x. Everybody okay with that? Yeah, absolutely, absolutely. So when I set this up, the area of the large rectangle would be 2x plus 12 times 2x plus 8. Now, to that area, since I've got to cut the hole out, I need to subtract out the red rose bushes, which had an area of 96. Now, the other thing that was going on in this problem, is that they wanted your area of the yellow roses to equal the area of the red roses. So now you set it equal to 96. Okay? We okay on that? All right. Couple things we can do. FOIL. When I FOIL out this part here, we get 4x squared. 2 times 8 gives me 16x. 2 times 12 gives me 24x. 24 and 16 is? 40. Area of the 1? 40x. And then 12 and 8 multiplied out is 96. Everybody okay with that so far? Yeah. All right. Is it okay if I cross off the 2 positive 96s? Here's what I'm doing, because eventually, if I subtract the 96 over here, that goes away, and this becomes a 0. Do you agree? Mm-hmm. This 96 doesn't change. Even if I moved it later on, it still becomes negative 96. We okay with that? Yeah. Now, what's your first rule of factoring? Factor out of 4, and you get x squared plus 10x plus 24, I believe? Oh, I'm sorry, this is minus 24. Okay? We okay on that? Yeah. Now, since I'm using this as a set equal to 0, does this 4 over here have any relation to the problem anymore? No. I don't care about it. It's not like, you just leave it. What times what is negative 24, but yet you add it together, you get positive 10.
12 and 2. 12 and 2.
12. So now, what are your zeros?
2 and negative 12.
Very good. Our zeros are negative 12 and 2. When I'm looking at this problem via the rose bushes, which one of those makes sense? 2. So what is the value of x then? 2. Does that make sense? But, all right, what's 2 plus 2? 4. Plus 8.
10.
12. I know. It's okay. Tilt your head sideways, it becomes a win.
Okay.
Boy, you just turned to beat your head. So, all in all, it's not that bad. What a lot of people were doing is that we're messing up into here. They were forgetting that when you're finding an area of shaded region, you back out the unfavorable spot.
Why do you not care about the full?
Well, what happens here, if I'm going to go ahead, you do agree that what we're doing is we're eventually solving this equation for x. When 4 is out here, it's 4 times all that junk. How do you undo multiply? If I divide it by 4, what's 0 divided by 4? 0. See how it doesn't change? That's why whenever I'm solving something that has an equal 0 and there's a coefficient up front, I don't care. I really don't. It works out just fine. Okay? What else do you want to look at? Yes, ma'am?
Okay, wait, no.
No, only if there's an equal sign.
Okay, so we did, okay.
Yeah.
Okay, and then minus Can we go over 4650?
46.
82.
46. Ooh, this one's nasty. 4 times 27, so that'd be what, 54, 108? What times what is negative 108, but yet you add together to get negative 13?
Nothing.
Nothing?
Yeah.
So, no solution.
I was right.
Or just.
Or no.
No. Yeah, it's fine.
Say no.
Looks like a man wearing a hat.
Empty set, no solution. Yes, ma'am. That's right, you were saying that too, Lisa. Sorry. Or Destiny, right after me, please. Yeah, 82. What is that, 7 and negative 5?
Yeah.
Yeah, I wrote 18.
One of the things we didn't really talk a whole lot about because I was kind of avoiding defining it was the intercept form. Because when you get down to your factored parts, those two terms themselves, the zeros of this are where this graph will cross where it crosses the x-axis. Okay? I wasn't worried about defining intercept form yet, so if that's what your question was, I totally forgot that was in there. I'm going to worry about the different forms when we go to graphing later on.
Okay, so you just want to say.
Basically, if there's an equal sign, get the zeros.
Okay.
From yesterday, that's fine. That's all it really was.
Okay.
Emily, you had one a second ago too.
I was just saying, it needs to say know how to write.
It's the same idea. You just get done with their two terms, and that's technically is your intercept form.
So just say,
Yeah, that's fine. Yeah. Yes, ma'am. 50? All right. Then we'll get going into today's stuff. In 50, we're looking at what times what is positive 4, you add together, get negative 4. Negative 2, negative 2. Is it okay if I switch it to x's? Go with your GCFs. We get a 2x minus 1. Take out the negative 1, you have a 2x minus 1. It's the term so nice you can name it twice.
Yeah.
You could write it as 2x minus 1 quantity squared, or 2x minus 1, 2x minus 1. Either way is perfectly legitimate for me.
I got negative 2x plus
Works out the same.
1. Okay.
Yes, sir.
Can you do 62?
Which one?
62.
All right. Last one now. What is your first rule of factoring, my friend?
Oh, factor out the 16.
There's no 60 in there.
No.
6x. 6x.
First rule of factoring is GCF. Go to the next problem.
Hey.
Oh,
That's it. It's one of those tricky ones that are thrown in there from time to time. Anna was asking me about this one earlier. What happens now, let's say if it said that, what would you do?
just sophomore.
Good.
Cry? No, there's no crying in math. You just said both terms equal to 0. What are your two zeros then?
6.
0.
0 and 6. Yep, that's all it is. Okay. You'll get something like that from time to time. All right. Make sure your name's around that, send that up, and let's get going into 5-3. What we're going to wind up doing in 5-3 is we're going to be working a lot more with taking square roots. Which means I want to remind you guys how you simplify radicals. We're also going to now this is the stuff you guys did last year in geometry, especially second semester. when you guys did all the right triangle stuff. 45, 45, 90, 30, 60, 90s, you had the root 2s and root 3s. Sometimes you had to rationalize denominators. Well, we still do that exact answer stuff here in Algebra 2. So just a quick refresher on what that stuff looks like. I believe last week, I think I showed you guys the shortcut for simplifying in your calculators for regular numbers. Remember that? Okay. Take your calculators out real quick. Now, some of these values are ones that you've probably done in the past. Remember, when you're simplifying a radical, you're looking for the largest perfect square. What's the, you know this off the top of your head. What's the biggest perfect square that goes into 24? 4. So everybody knows that 24 can be rewritten as the root 4 times root 6. Therefore, your answer is 2 root 6, right?
What?
How'd you get that?
Because
Perfect square.
What's the square root of 4?
Oh, yeah, I don't understand this.
You're looking for the biggest perfect square. Biggest perfect square that goes into 24 is 4.
Does our calculator do that for us?
What's 4 times 6? It's a composite square. What's the square root of 4? What's the biggest square root that goes, biggest perfect square that goes into 90? 9. So I can rewrite this as square root of 9 times the square root of 10. 3 root 10. Now, what I was saying is, for those of us that have forgotten some of these simpler ones, there is a little bit of a way of your calculator being able to do that. If you go to your y equals button, and just to show you how it looks, square root of 24. What I'm going to do is type in 24 divided by x squared. Go to my table. What I'm looking for here, let me scroll up, starting at 1. Notice what it's doing here. It's saying 1 and 24, 2 and 6, 3 and 2 and whatever, 4 and 1.5, 5 and 0.96. What you're looking for is the largest value, or excuse me, the smallest value without a decimal, an integer, in the y column. See, it says 2 and 6.
Oh.
Yeah.
So that means it is 2 root 6.
Oh, that's so cool.
It's a nice trick for this calculator to do that. The other calculators you guys used last year, those multi-views, you press the button, it did it for you. This one you have to do a couple extra buttons, key presses for. The other one in here was the square root of 90. Do the same thing. 90 divided by x squared. Go to your table. 3 root 10. Yes, ma'am?
Is this going to be part of your calculating course?
What's going to happen here is that you have to get, when we get to questions on these things, your answers have to be in simplified radical form. So you need to know how to work with radicals. This is a little bit of exercise in it. If it takes us a day to go through it, it takes us a day. It's not a big deal. Okay? The other part here is when you're dealing with division. When you're dealing with division of radicals, basically fractions of radicals, you can't do that same shortcut because the calculators won't do the fraction part. But what you're doing here is you're taking the square root of 7 divided by the square root of 16. What's the square root of 16?
4.
And there's your answer. Because you can't simplify the square root of 7. We okay on that?
Yeah.
All right.
So you just leave it as that?
You just leave it as that,
And
yeah.
then if it's like, you can't simplify any of them, you just split.
And that's when you get to the next one.
Okay.
When you get to, yes ma'am. When you get to the square root of 7 over the square root of 2, you have to go back and remember, square roots are not happy in the denominator. You want to what we call rationalize. Yeah, this is where you're multiplying by a factor of 1. It's weird how I write this. What is the square root of 2 divided by the square root of 2? 1, right? So all I'm doing here is multiplying this first fraction by 1. In doing so, I am changing the denominator. Because what's the square root of 2 times the square root of 2?
Square root of 4 is 2.
Right. Square root of junk times the square root of junk is junk.
So
So negative root.
So what's 7 times 2?
14.
That's how you rationalize. Okay. Yep, that's the simplified version of the square root of 7 halves. No, it's not true. Okay. We spend a lot more time later on working with these radical fractions later, but this is just kind of a quick heads up on what it's going to look like. Because when we get into the rest of the stuff today, we're going to be doing stuff like this.
Yay.
We're going to solve the equation with exponents. Now this shouldn't be difficult because we've done stuff like this, a little bit like this with the sequences in series. Okay? Now in this case here we have 2x squared plus 1 is 17. Just working off, please excuse my dear Aunt Sally, working backwards, what do you move first? Working backwards. The 1. I want to get x by itself. I got to move the 1. How do I move a positive 1? Subtract. Divide by 2.
8.
Now, how do you undo squaring?
You square.
Square root it. Here's the trick. We took a square root over an equal sign. Do you agree? Whenever you take a square root that's over an equal sign, you will always have 2 answers, a positive and a negative. You get the plus minus square root of 8. Now, the square root of 8 should have been one that you remembered from last year because it was very common in geometry to see the square root of 8.
2 root 2?
2 root 2. You guys okay with that?
Yeah.
Remember, it's 4 times 2, so you get 2 root 2. So your answer here for x would equal plus or minus 2 root 2.
Wait, why is it plus or minus?
Whenever you take a square root over an equal sign, it's always going to be 2 separate values. Because remember, there's always 2 numbers that you can multiply together to get that positive value. For example, 2 times 2 is 4. Negative 2 times negative 2 is also 4.
Okay.
So by putting that plus minus there, it's alleviating the issue of having that without doing it. Okay? When we get to imaginary numbers, we might be looking for a singular value, but that's next week.
Oh, imagine.
Oh no! There's our fractions! I am so scared! Christian, are you scared? Good! It's for later. He's in another class.
Are you talking about minus?
Yes.
Yeah.
Alright, so how do you undo a fraction? By its,
Opposite.
which is called the reciprocal. Multiply both sides by 3.
Okay.
And now you get x plus 5 quantity squared equals 21. Can I move the 5 first, or do I have to take the square root first? Square root, very good. In this case, we have to take the square root of both sides first. Square root of 21. Does everybody agree that you can't simplify that?
Yeah.
Okay, good. So we have x plus 5 is plus or minus the square root of 21. Anytime you take square root of an equal, gotta go plus minus. How do you move the 5? You subtract. Now here's what I want you to do. When you move this over, do you agree that it's a negative 5?
Yeah.
Put that prior to the radical. Put it in front. Negative 5 plus or minus the square root of 21. The reason why I like to do it that way is so that way you don't accidentally tack in a minus 5 here and write 16. See what I'm saying? Put it in front. Anytime you've got an integer value, put it prior to your radicals. It's kind of like what they call mathematical etiquette. It's like working with the furthest outside fork of your first dish. Or keeping your pinky when you're sipping your coffee. Yes.
I don't know if this will ever happen, but like, what if the original equation inside the parentheses was like negative x plus 5? So then in the end, you have like negative x equals negative 5 plus minus.
Then how do you undo multiplying by a negative?
You multiply by negative 1.
Right.
how would you multiply plus or minus by negative?
What's a negative times a positive?
Negative.
What's a negative times a negative? Does your solution change?
No.
No, it's a great question. But you see how it's not going to when you have that plus minus, you multiply it by a plus minus, you still get minus plus, but that's okay. It's a good question. Let's do 14.
Yes.
Take a second, try that one. Try let it run.
Yeah.
Every once in a while I have an idea.
That was a natural. You can tell I have a.
Yeah, whenever you take a square root over an equal sign, go into the plus minus. Oh. It's still plus or minus. Because what's the square root of 4?
Oh.
See how you took the square root of both sides? You always do both sides. Always, always, always. I'm assuming that this probably wasn't very tricky.
Oh, wow. Wow.
Why would you do the square root first?
You can't.
Why? This is stupid.
You have to work this way. To undo stuff, you have to work the opposite of PEMDAS. It's sod method. You got to work sod method. And then when you take a square root over an equal sign, what are your solutions? Okay. That's how that works. All right. You cannot take the square root right there where it says 4x squared is 16. You cannot do that. You will be wrong.
Yeah, I know.
Okay. Let's do.
Wow.
We'll throw another fraction one in there, see if you remember how to work with fraction. Don't say it's the same thing. Well, no, because you went up, you multiply the left side by 6, you get 6 over 6, which is. So yeah, square is 12.
Hey, Mr. Murphy, I got 100 fun on that.
Always be happy.
I tried. Don't get angry and throw your stuff. It's just math. Oh, Bobby McFerrin, you're so funny. All right, let's see how we did. Add 2 to start with, I'm hoping, right?
Yes.
Multiply both sides by 6. Square root of 12. X is plus or minus 2 root 3. Good.
Oh, so.
All right. You'll see that same kind of things happened from last year. Square root of 8s, square root of 12s, 18s. Those show up pretty consistently. You're gonna know them off the top of your head. 24, 2 root 6. You'll start to pick up on those really fast. There's really not a lot of scariness here, hopefully.
Is this all we're learning? Is that like
Yeah, I kind of want to do one more hard one though, because that's just me.
Alright.
Because we'll get into the word problem stuff and this stuff by tomorrow.
We have homework tonight.
I want to walk you through how you set this up. Okay? Yeah, absolutely. Use an X. I'm going to walk you through an easy way to set this up right off the bat. As of right now, most of you guys are all going, it's a fraction. Especially Molly. Molly hates fractions.
She does.
No. So I want to get rid of my fractions. In doing so, I'm going to multiply everything to get rid of them. What is the least common multiple of 2, 5, and 10? 10. Good. If I multiply both sides of this equation by 10, my fractions drop out. Let me show you. If I multiply everything by 10, that means I'm going to distribute the 10 to all 3 parts. You okay with that?
Yep.
So basically you wind up with 10 times the x plus 1 quantity squared over 10 minus 10 times 12 over 5 equals 10 times 15 over 2. Everybody okay with that?
Yes.
What's 10 over 10?
10.
One. It's 1.
1. Okay.
What's 10 divided by 5?
2.
2.
And 10 divided by 2.
5. Hold up. 5.
Have my fractions gone away?
Yeah.
Yes, yeah.
Now it's an easy problem.
Wait, what? How did you
My gosh.
cross them out?
What's 10 divided by 5?
Yeah.
What's 10 divided by 2? I'm just all I did there was simplify my fractions. That's it.
Wait, what's the number after the 15? 5 times. Why is it 5?
Wait, yeah. What was that?
10 divided by 2 is
Was it
15.
Oh, you like it to 2 by 5?
Pitch money in.
10 divided by 5 is how much?
2? Well then why is why is
Because I'm doing 2 times 12 now.
I can see it.
What's 2 times 12? 24, okay. What's 10 times 12 divided by 5? Dun, dun, dun. 24. I simplified my fraction. That's it. Simplifying fractions is the easiest thing to do. That's why you're getting those common denominators, to wipe out the fraction to make it quicker. Now, if you wanted to go through and work it out, you get 120 over 5, you still divide it out, you're going to get 24. It's perfectly fine if you want to do that. I'm just doing the shortcut math by the short division. Okay? That's all. That's where I'm getting it. Homework then.
Wait, what's the
Yes.
-1 plus
I don't know.
3.
I haven't done it yet. I just felt like giving you a hint.
I got the answer.
Hey, Colin, how'd you do on your AP Chem test?
That's it.
Good job.
I mean, I would do it.
Don't fail AP Chem.
No, not really. I was gonna
I'm probably going to get a D minus.
No, I'm shooting for a B because that's really an A.
Let's do these for homework-wise. Let's go. We'll just start easy here on page 267. This is section 5.3.
1 through 2 odds.
No, it's 52 through 53 odds. Oh, okay. Okay.
And
Oh, that's it. Then. And then that's it.
That was, oh.
And that's it. Come on. Don't do it to it. Alright. Oh, it's
Okay.
You can't be kidding me.
do those quick setups. It's really not a lot there. Just remember when you're working with the radicals, whenever you take a square root over the equal sign, you have to go plus minus. Okay? Gotta have plus minus. You will be doing a lot of that simplified radical form. When you get your answers, if you're not sure what the square root of 68 is or how to work with a fraction with the radical in it, you want to save that for tomorrow to kind of go over it again, that's fine. But over the next few days, we're going to be working solely with radicals. Yes, sir? Yeah, you still got 15 minutes. You got time. Let's go.
Let's finish.
Oh, come on.
Don't have my phone.
Have a phone, though.